Here are the solutions to review sheet number 4 for the second semester exam. We begin by a problem involving a right triangle that needs to be solved. The problem is giving us two sides. Side A is 5. Side C, the hypotenuse, is given as 13. So it's our job to solve for this other leg, side B, and then we also need to find the measurements of these two angles, A and B. So to find a missing leg of the triangle, since both of these are non-decimal numbers, it's safe to use the Pythagorean Theorem. Otherwise, I would probably try to find one of these angles first and then use a trig ratio, but we can go ahead and jump into using the Pythagorean Theorem here. So c squared is a squared plus b squared. So c squared, the hypotenuse, is 13, and side A is 5. And we're trying to find b, so this is going to be 169 minus 25, subtracting 25 from both sides, equals b squared. 144 is b squared, so b, side B, is 12. Okay, so we got one of our missing parts discovered, and now let's work on these angles, either A or B to begin with, really doesn't matter. So let's just imagine that we wanted to find angle A. Okay, maybe I'll just put a little theta here. Again, I'm trying to find the missing angle A, and you have choices since, again, we've got all non-decimal numbers representing the sides. It really doesn't matter which way you go. You could think of, for angle A, using the sine ratio. Sine is the opposite side divided by the hypotenuse. You could also do the cosine ratio, which is the adjacent side, 12, divided by the hypotenuse. So it really doesn't matter which way you go. I'm just going to go, I guess, with the sine of angle A. And it's equivalent to the opposite side, which is 5, divided by the adjacent side, which is 13. And the way I solve for angle measurements is I use inverse, or some textbooks will call this arc sine. And anytime you're trying to find the measurement of an angle, you're going to do this inverse of whatever trig ratio you started with. All right, so now you'll want to grab your calculator and secant sine, and then you're going to put 5/13 in parentheses. And after doing that, you're going to have the measurement for angle A, and rounded to the nearest tenth, that'll be 22.6. Oh, I'm sorry, on the instructions you're told to round angles to the nearest degree. And so it starts off at 22.6 and following, but we're going to say to the nearest degree, that'll be 23 degrees. That's angle A, side B. And now we just need to find angle B, and we can use the knowledge that the sum of the angles of a triangle add up to 180 degrees. So we'll subtract the angle C, the 90 degree, our newly found angle A, 23 degrees, and plug that into our calculator, and that will give us the measurement for angle B. And that should be 67 degrees. All right, and that is your complete answer to number 1. All right, number 2. We're trying to find this distance from A to C. So in other words, for this right triangle that's pictured, we're trying to find this leg that is opposite this 25 degree angle that we're given, angle B. So again, you're thinking about a trig ratio. If you're thinking from this angle 25, you're looking out from this angle 25. You're looking for the opposite side, and you're given the adjacent side of that angle. So think about your trig ratio that involves opposite over adjacent, and that's the tangent ratio. So tangent for this 25 degree angle will be the opposite side, which we don't know yet, divided by the adjacent side, which is given. And so now to solve for x, I just multiply by 50 on both sides. And once again, we'll turn this over to our calculator, and we'll do 50, tan, and then in parentheses, we'll put 25. And rounded to the nearest tenth on this problem, that length, and these are in feet, of course, this would be 23.3 feet. So that distance across the river will be just over 23 feet. And just once again, I know I mentioned this in class, but be prepared for any scenario. I might give you a side, two sides, and have you find the angle. So you should be prepared for any particular type of problem where information is given and you're trying to find one particular piece of the right triangle. So remember, if you're looking for an angle measurement, that's going to involve inverse, sine, cosine, or tangent, whatever applies in the particular problem. Okay, so there's your answer for number 2. 3 and 4, we're converting from either radians to degrees. That's what will happen in number 3. This isn't radians, we'll convert it to degrees. And then of course this is degrees. How do we convert that to radians? So our conversion factor, when we convert from radians to degrees, will be this factor. Remember, we always, if you want a suggestion or a tip, you should always look diagonally from the numerator of the given problem to the denominator of your factor. And you should notice that pi matches up, okay, because eventually we want pi to cancel. And that's the way we'll accomplish that. Okay, so now we can do some reducing, dividing 6 into both of these. 6 goes into itself one time. 6 into 180 degrees is 30 degrees. And now we can do 30 degrees times 7, and that's 210 degrees. So that's my answer for number 3. Number 4, it's just the opposite conversion factor. Now we're going to do pi radians over 180 degrees. Notice how if I put this fraction over 1, put it as a fraction over 1, now my degrees line up, degrees will cancel, and I'm going to be left with some factor of pi for the radian measure. Okay, so I'm just looking for a way really to reduce. I'm just going to cancel the degrees, and this is going to be some fraction multiple of pi. If I notice 20 goes into both of these numbers, 20 goes into 189 times, and 20 goes into 380 19 times, and that gets us to our final answer. This will be 19 pi over 9, and that is the radian equivalent of 380 degrees. Okay, our next problem involves finding the arc length of a circle, and you should be familiar with that formula. Its arc length, denoted by this letter S, is the radius of the circle times the angle measurement given in radians. Okay, so we're given both of those pieces of information. We know the radius of the circle is 14 feet. We're given the angle measurement, but it's in degrees. So we're going to have to do a little conversion, sort of like we did previously, because you must convert this into radians in order to use this formula properly. All right, and so really there's no need on the previous problem. We wanted to come up with a multiple of pi answer. In this case, you can just stick all of this in place of theta and just use your calculator, because we're trying to come up with an actual length of this arc. If we drew a picture of the whole circle, we want to come up with, I'll just shade it in for you. It rotates 330 degrees, almost a full revolution. So we want to know what is the length in terms of feet of this blue shaded arc of the circle. Okay, and so we'll start with the radius, which is already in feet, and then you can just plug this into your calculator, 330 pi divided by 180. So it's like doing the conversion, and it's also just leading us to our answer, just letting the calculator do all the work. And so 14 times 330 pi and then divide that by 180, and you should show in your calculator that it's 80.634211, but we're rounding to the nearest tenth. So the length of that arc described in this problem is 80.6 feet, rounded to the nearest tenth. And that's your answer for number 5. Number 6, we're told that the terminal side of some angle theta in standard position passes through a particular point. So let's just do a little sketch. Let's show the point 6, -2. And there's the point, 6, -2. Here's the terminal side. And remember, this is called the initial side of that angle. So we have the initial side and the terminal side. Theta will always be interior, close to the origin. And so you're basically going to form a right triangle. And there's the right angle. I just dropped down a vertical to go with this horizontal, forming the right angle. And this side of the right triangle will be 6 units, because I went 6 to the right. This side of the right triangle will be 2, because I went 2 down. And to begin with, we need to find the hypotenuse. So we need to find out what this side is opposite the right angle. So once again, we'll turn to the Pythagorean Theorem. The hypotenuse is always c. So c squared is a squared plus b squared. C squared is 40. C is the square root of 40. Remember, we always want to have exact answers in these problems, so make sure you simplify radicals when necessary. And the square root of 40 does simplify into, well, I'll just show it as this, the square root of 4 times the square root of 10, which reduces or simplifies to 2 times the square root of 10. So now we know the 3 sides of this right triangle, and we can go to making all 6 trig functions of theta. Okay, everything is in relation to theta, which is always near the origin. So we're looking this way. All right, so we'll just start with sine theta. Just come over here, give myself a little bit of room. Okay, sine theta is the opposite side over the hypotenuse. So it'll start like this. And when we reduce, we get 1 over the square root of 10. And we always want to rationalize. So we don't want to leave radicals in the denominator. And so sine theta will just be the square root of 10 over 10. Okay, let's go to cosine theta. All right, so here's theta. That's the adjacent side over the hypotenuse. And 6 over 2 is 3. And once again, we can rationalize, or we need to rationalize, by using root 10, top and bottom. So that'll be 3 root 10 over 10. And we'll come down here and do tangent theta. All right, so for theta, the tangent will be the opposite side, which is 2, divided by the adjacent side, which is 6. Reduced, that's 1/3. All right, so now we'll work on the reciprocals. So the reciprocal of sine is cosecant. And if we know sine, we can just take that and flip it over. So you might want to just take this initial one, flip it over, and it would look like this. And then the 2's cancel, and you just have the square root of 10. The reciprocal of cosine is secant. So once again, if you just take the original 2 root 10 and over 6, and these would become 1 over 3, so it's the square root of 10 over 3. And then finally, cotangent is the reciprocal of tangent, which is 3. Now, one thing I want to make clear I haven't done yet is I've just run through all of the trig ratios, trig functions of theta. But we have to remember, and a lot of people are forgetting this, we have to remember in quadrant 4, the ordered pair looks like this. The x-coordinate is positive and the y-coordinate is negative. That means when we're looking at ratios, remember x corresponds to cosine and y corresponds to sine. Okay, so before you finish your answer, since this terminal side falls in quadrant 4, you've got to make sine negative. Okay, I just wanted to emphasize that here at the very last. Sine is negative. Cosine will stay positive. Well, if one of these is positive and one negative, which is the case in quadrant 4, that means tangent has to be negative. Okay, it's like sine over cosine. That's how you describe tangent. Negative divided by positive. Okay, if sine is negative, that means cosecant has to be negative. Cosine is positive, so secant will be positive. Tangent is negative, that means cotangent also has to be negative. It's just the reciprocal. So again, be careful. Some people are getting the ratios correct, but they're failing to remember how the signs work within each quadrant. So pay close attention to what quadrant the given point that will be provided, what quadrant does that fall in, and then let that help you discover or determine how the signs work with each trig function. All right, that's your complete answer for number 6. Number 7, this will utilize your information, your knowledge of the unit circle. So once again, you may not have to draw the whole unit circle, but you should at least be knowledgeable of the first quadrant, and then you can change your signs accordingly, sort of like what we just talked about. So remember, for this 60-degree angle, space this out just a little bit. This is 1/2, meaning cosine is 1/2, and then square root of 3 over 2 sine. For this 45-degree angle, they're both root 2 over 2. And for this 30-degree angle, it's root 3 over 2 for cosine, 1/2 for sine. Okay, so we need to understand where this angle falls. All right, so 270 degrees. All right, so here's 180. Here's 270. So this is one of those angles we call a quadrantal angle because it helps divide our coordinate plane into quadrants. So cosine 270 means we fall right here. And the ordered pair at that 270-degree angle is 0, -1. Cosine is always the x-coordinate, and so we would say cosine 270 is 0. And that's our answer for number 7. So for number 8, let's start off at the initial side here, positive x-axis, and let's go 150 degrees. All right, we'll estimate that to be 150, which means we're going to be dealing with a reference angle of 30 degrees. Reference angles will always be made between the x-axis and the terminal side of another angle. So let's look at I know this isn't a great drawing, but let's look at our 30-degree angle that we provided in quadrant 1, and remember that in quadrant 3, excuse me, in quadrant 3, both of these are negative. Negative root 3 over 2, -1/2. Okay, and sine always corresponds to the y-coordinate, and so very simply, we'll just take the y-coordinate of this angle from quadrant 3, and we'll say our answer is -1/2. Number 9, we are looking at the angle 3 pi over 4, Okay, so maybe I'll do a different color here. So starting here and going 3/4 pi. Well, this would be like 1/4 pi, 2/4 pi, and then 3/4 pi. Use me. So it's the 45-degree reference angle. All right, so I'm looking at the 45-degree angle over here in quadrant 1, but the sine's over here in quadrant 2. The x-coordinate will be negative, and the y-coordinate will be positive, which means for this angle, cosine is negative root 2 over 2, sine is positive root 2 over 2. We're interested in cotangent. Well, tangent is y over x, or sine over cosine. So all I have to do is think, well, cotangent is the reciprocal of that. It's x over y, or cosine over sine. Either way, we're going to get -1 because anything divided by itself would be 1, but in this case, we have one positive and one negative. And so when we take cosine or x and we put it on top of y, sine, we're going to get -1. And that's my answer for number 9. Okay, so number 10, we're getting a crowded unit circle up here, so let me see if I can fit one more. -7 pi over 3, you could think of that as -2 and 1/3 pi. All right, so here's my negative direction. I'm going all the way around. That's -2 pi. And then I'm going to go another 1/3 pi. Okay, so my reference angle is pi over 3, or 1/3 pi, or you could think of that as 60 degrees. So I'm looking at the 60-degree angle that I formed up here in quadrant 1, but changing it so that it's properly reflected in quadrant 4. The x-coordinate is positive in quadrant 4, the y-coordinate is negative. All right, and so I'm working with this ordered pair, and I have to understand that secant is the reciprocal of cosine. Okay, well, if I know cosine for this angle, which is 1/2, to get secant, I just take that and flip it over. So the answer for number 10 will be the reciprocal of 1/2, which is 2. And that's my answer for number 10. So make sure that you understand the unit circle. Okay. Number 11, define the period of the following function. Well, the period, just by way of review, is the horizontal distance of the pattern where the graph starts to repeat. Okay, so let's trace this graph and to understand its characteristics here. So it goes up, down, up. Okay, so it looks like at this point you can see repetition. It's really that same graph over and over again. So the way to define a period is the horizontal distance of that pattern that repeats itself time and again throughout the graph. And so very simply, we don't know what these units are, but we would say that the period for number 11 would be 4. Every 4 units, it does the same thing. It repeats. All right, and so that's our answer for number 11. Number 12, the way to determine amplitude. If you're looking in general, I'll just give you the general statement. I'll call this B. Whatever A is, the absolute value of A will be amplitude. Okay, and so that's pretty simple. In this case, for number 12, that would be 6. And then whatever B is, the way we find period is we always take 360 degrees and we divide by b. Okay? And so in this case, that would be 360 degrees divided by 2. So the period for this problem would be 180 degrees. And that is number 12. Okay, let's do a couple of graphs. We need to identify amplitude. So based on what we just saw in the previous problem, the amplitude would be 2. That means it's going to extend to 2 positive going up the y-axis and 2 negative going down. All right, and now let's do the period. All right, we just saw how that works. It's 360 degrees divided by whatever is in front of theta, and it's understood to be 1 in this case. So the period is 360 degrees. And then just for our purposes, what is the graph interval? And that just means what will these markings be on the theta axis. And the way we get that, and you can always remember it, we're going to have 4 marks on the positive side. So just take the period, whatever it is, and divide it by 4. And that will tell you how to divide these markings up. What will their units be? And so these will be in 90-degree units. And so when you're graphing these, you can think of these as inputs. Notice how I've called this horizontal axis the theta axis. So you can literally input these numbers one at a time, and it will help you to come up with the ordered pair. So these will be inputs. We'll start at 0 degrees, and then we'll come up with outputs, and that will make it easy to plot. So we'll start at 0 degrees. We have to understand what cosine 0 is. Okay, so again, we're just really doing another display of the unit circle. The 0 degree angle has the ordered pair 1, 0. So remember, cosine is x. So cosine 0 degrees is 1. And now we'll do 2 times 1, and we get 2. All right, cosine 90 degrees, that's the ordered pair 0, 1. Cosine is x, so cosine 90 degrees is 0, and 2 times 0 is 0. For 180 degrees, that's the ordered pair negative 1, 0. Cosine is negative 1, and 2 times negative 1 is negative 2. All the way to 270, the ordered pair is 0, negative 1. Cosine is 0 for 270. 2 times 0 is 0. And then all the way back around, we've made one complete revolution, which for this problem is the period. We're back to cosine 1, or cosine 0 is 1, and 2 times 1 is 2. And that's our graph, and we'll just show the positive side, so we'll have to come up to 2, and then we just go through all of these points. And then we'll just show heading back down in that direction. And that is the graph for number 13. Number 14, similar type problem. This time the amplitude is 1. It's understood to be 1 multiplied in front of sine. So we'll do 1 on the top and negative 1 on the bottom. The period will be 360 degrees divided by, in this case, 2, which is 180 degrees. So our pattern should repeat every 180 degrees. And for our graph interval, the units on our theta axis, we will do 180 degrees divided by 4, and that is 45 degrees. So these markings will be 45, 90, 135, and 180. And then we'll do the same thing we did before. We'll start at 0 degrees. So if you need a picture for 0 degrees, the ordered pair is 1, 0. Sine of that angle is 0, and 2 times 0 is still 0. So it's still saying sine 0, and that's 0. Okay, now we're going to input 45, so it's really, you can think of it this way. So you're, in essence, you're doing sine 90, okay, because 2 times 45. So up here is the 90-degree angle. All right, so the sine 90, the output would be 1. That's the y-coordinate. So for input 45 into theta, we get an output of 1. Okay, when we input 90 in for theta, it's like doing this. So we're actually doing sine 180, 2 times 90. And that's 0, the y-coordinate. When we input 135, just following the same pattern, it's like saying sine of 270, 2 times 135. Okay, and that's -1, the y-coordinate. And when we input 180, that's the same thing as sine 360, 2 times 180, and we're back to 0. Sine 360 is 0. All right, so we'll just come up through this and connect our dots. And something like this, it'll go up to 1 and then head back down. It's going to go down to 1, but then head back up. But that's the rough sketch of this particular graph for number 14. Okay, we're almost done. I want you to be familiar with how to handle rational, that means fraction, exponents. And here is number 15 in radical form. The bottom part of the fraction will be your root, and the top part of the fraction stays with the base as an exponent. Okay, I don't want you to use a calculator here, but you can think of this, if you broke this up into 2 parts, you're not changing anything if you say the cube root of 8 and then square that result. When you break it up into 2 parts like this, it makes it pretty easy to compute. The cube root of 8 is 2. And then we're just going to raise 2 to the 2nd power. And so it's really a 2-part answer. I want you to show me the radical form and then simplify. So the second part of that answer would be 4. For number 16, I'm going to change this into positive exponent form first. Okay, remember what negative exponents do. They cause us to write the reciprocal of the base. And now let's look at that denominator in radical form. It would be the square root of 64 cubed. Okay, so let's break that up into the square root of 64 cubed. You see how it looks really complicated without a calculator, but when we break it up like this, which is an equivalent form, it's not so bad. It's the same thing as 1 over square root of 64, which is 8 cubed. And if you can't use a calculator, but 8 times 8 is 64, and then you're just doing 64 times 8, which is 512. And that is the 2-part answer for number 16. And that completes this review sheet, and the only thing left will be your conic sections, and you have a review sheet for that material that you were given for the most recent test. And so that's what you should study again to get ready for the conic sections part of your semester exam. So hope this helps. Let me know if you have any questions.